All right, we're going to do section 9.3, page 461, number 1, which reads, show that e to the x grows faster than the polynomial x cubed minus 3x plus 1. So let's start by letting f of x be equal to e to the x. And we're going to let g of x be equal to the polynomial x cubed minus 3x plus 1. And if f of x grows faster than g of x, then we've learned in this chapter that that means that the limit as x goes to infinity of f of x over g of x is going to be equal to infinity. So the way to attack this problem is to take the limit as x goes to infinity of f of x over g of x, and whatever that is equal to will tell us whether f of x or g of x grows faster. So let's start by substituting in here. So I've got my limit as x goes to infinity of e to the x over x cubed minus 3x plus 1. And there's not really a lot of algebra I can do here, a lot of manipulation. I really just kind of need to substitute in. And when I do that, I get infinity over infinity. Now this is an indeterminate form. It's not a final answer, but it is an indeterminate form that we can use L'Hopital's rule for. So when we do L'Hopital's rule, I'm still taking the limit as x goes to infinity, and then I take the derivative of the numerator, which is going to be e to the x, and I take the derivative of the denominator separately, which is going to give me 3x squared minus 3. And again, I'm going to substitute in, and that's going to give me infinity over infinity. Still have an indeterminate form, need to apply L'Hopital's rule again. So when I do that, I've got my limit as x goes to infinity, and the derivative of the numerator is still going to be e to the x, and the derivative of the denominator is going to be 6x. Again, not a lot of algebra that I can do, just need to substitute in, and that's going to give me infinity over infinity. Still, indeterminate form, need to apply L'Hopital's rule again. So I've got my limit as x goes to infinity. The derivative of e to the x is still e to the x, and the derivative of 6x is going to be 6. Now, when I substitute in, I'm going to get infinity over 6, and that is actually going to be equal to infinity, which tells me that my criteria up here that says f of x over g of x in the limit as x goes to infinity will be equal to infinity, that's telling me that f of x has to be bigger than g of x, or e to the x has to grow faster than x cubed minus 3x plus 1.